Institute of Technology, Sangli, Maharashtra. Dr. Anand Kakade received MTech and PhD degrees from IIT Kharagpur in year 2005 and 2010 respectively. He has get 2003 score of 99.59 percentile with 129 AIR. He has 13 years of teaching experience and 10 years of experience in electronic product design. He developed more than 18 electronic products, out of which 12 are commercialized. He has filed 14 patents, out of which 2 are granted. He has received several prestigious awards for excellence in R&D. He received Dr. M.M. Sharma Award in Science and Technology from Marathi Vigyan Parishad in 53rd Annual Convention on 22nd December 2018 at Chalisgaon, Maharashtra. Award consists of cash prize of rupees 1 lakh, trophy and certificate. He received Best Engineering Teacher Award from Engineering Education Foundation, Pune on 8th October 2018 at Nashik. Award consists of cash prize of 10,000 and certificate. He received IUCEE Showcase Award for Leadership in Community Project-Based Learning on 8th January 2020 at Anurag Group of Institutions, Hyderabad, Telangana. Award consists of cash prize of rupees 5,000 and certificate. He also received Distinguished Professor Award by CSI Tech Next 2017 at IIT Bombay. He received funding of rupees 1.2 crores from various funding agencies for implementation of different projects. He has 13 publications in Refereed Journal and he is reviewer of Refereed International Journal. So with this, I request Dr. A.B. Kakade sir to continue the session. Please, sir.
Thank you, Professor Jagtap, for kind introduction. I hope I am clearly audible.
Yes, sir. Yes, sir.
Yes, sir. Audible.
Good afternoon, one and all. I am going to deliver session on IoT based products developed by me. Especially, I will present case study of one of the IoT based product in detail. This is outline of my presentation. I will talk about some of the products developed by me in short. After that, I will talk about malfunctioning of embedded IoT products. It is really interesting topic. I will spend around 20 minutes on discussion of causes of malfunctioning of embedded systems or IoT products. Then I will talk about limitations of Arduino and Raspberry Pi boards, which are extensively used in most of the engineering colleges for development of projects. Then I will present in detail case study on IoT based saline monitoring system, which is developed by me. Then I will present case studies on IoT based water management system that we implemented in our campus. And then finally, case study of IoT based non-conductive liquid measurement. So this is outline of my presentation. Let me tell you, my specialization is RF and microengineering. But for last 10 years, I am engaged myself in the development of embedded products. So whatever spare time I get, I utilize that time for new product development. So I have already mentioned that I have startup Anand Techno Creations and I am full-time professor in Electronic Department of Rajaram Bapu Institute of Technology. So these are some of the products developed. This is dual channel smart DC regulated power supply. It has interesting features. This power supply has short circuit detection mechanism. So whenever there is short circuit across the output, it immediately forces the output voltage and current to zero, thereby protecting internal MOSFETs. And at the same time, it produces beep. So this beep is indication of short circuit condition. So while conducting experiments, student may do accidental or deliberate short circuit. So this power supply is able to detect short circuit condition and internal components are protected. Whenever short circuit is detected, it flashes the message of short circuit. And all the parameters like voltage, current limit and load current, they are simultaneously indicated on the display. In addition, I have used different type of circuit like I use 4 MOSFETs in series to dissipate the excess heat. So therefore, life of the power supply is long because of 4 MOSFETs in series. The next product developed is automatic curd making machine, on which I filed 3 different patents. So in this machine, user can get same quality curd every day. There is tartness sensing mechanism developed for this automatic curd making machine. Then in the same machine, it is possible to detect harmful adulterants like urea, detergent, preservative if present in the milk. So this harmful adulterants machine is able to detect during curd formation. So this machine is developed in 2 different capacities, 1 liter domestic capacity and 16 liter commercial model. These are the photographs of power supply developed for our department use. Next product is automatic water level controller. In fact, this is my first product which I developed way back in 2012, and I have sold good number of units into the market. 2 years back, we developed IOT based automatic water level control system. So earlier I developed only automatic water level control system, and when I connected it to the internet, it became IOT based automatic water level control system. So this water level control system I developed in different models, useful for controlling single phase motor and 3-phase motors. Again, separate models for submersible, non-submersible motors. And on the right hand side, you will see photograph of IOT based automatic water level control system. So while developing the system, I also look into the aesthetics of the product. Then other product developed are like wireless security system. It is GSM based, and at present I am planning it to convert it into the IoT based wireless security system. Then next product developed is long range occupancy detection system. It is useful for saving the electrical energy. So this product we have already installed in most of the locations in our college, like classrooms, corridors, washrooms. The interesting feature of this product is its detection range is 90 feet. So such long range systems are not available in the market. Then other simple products like programmable ringing bell. This product we sell to schools and colleges. During pandemic, within 2 weeks, we developed automatic hand sanitizer dispenser. And interesting thing about this product is within 2 months, we sold more than 1,000 units. And manufacturing of this automatic hand sanitizer dispenser we have done in our department with the help of lab assistants. Next product developed is IoT based saline monitoring and control system. I am going to talk about complete design cycle of this product in detail. So maybe after lunch break, I will talk about more in detail about this product. On this product, I have filed 2 different patents. I am also doing some kind of consultancy work for nearby industries. I have done notable consultancy work for Kirloskar Energy Limited, Kolhapur. The solution which I implemented over there is saving electricity of around 8 lakh rupees per year. And this system was implemented around 3.5 years back. And still it is in working condition. So let's move on to the important topic of my session, malfunctioning of embedded and IoT products. Whenever we develop any system, if it is not properly tested, it may malfunction at customer side. So major problems in any kind of embedded system is unwanted reset. Most of the embedded system make use of microcontrollers. And if system is not properly designed, microcontroller may get reset again and again. Another major issue is software hang-up issues. In previous session, Dr. Udpikar talked about software hang-up issues. So these software hang-up issues may be due to hardware problems or may be due to incorrect written software. So here my focus is on hardware aspects of embedded system. So these unwanted reset and software hang-up issues are most of the time due to electrical noise and sometimes incorrect specifications. For example, when embedded system is developed, each and every embedded system requires power supply. And in power supply, we have voltage rating and current rating. As an embedded system designer, we usually pay attention to the voltage rating of the power supply, and many times we do not look at the current requirement of the product. So for example, if current requirement of the product is half ampere and power supply that you have designed has current rating of 300 milliampere, then your product may malfunction because your product may consist of relays, several relays, and if several relays in the product are switched on simultaneously, it requires more current. And if power supply design in the product is not capable of delivering required current, then because of under current rating, your product may malfunction. Your power supply is not able to source the required current, so microcontroller will not get sufficient voltage and current. Say for example, if product requires more current and if power supply is not able to deliver that current, then voltage delivered by the power supply may get dropped. Instead of 5 volt, it may become 4 volt, and that may lead to the malfunctioning of the product. Another major issue is electrical noise. So most of the embedded system designers, they are not aware about electrical noise. This electrical noise is produced by various sources, and this lot of electrical noise is present on commercial AC supply. In India, we use 230 volt supply. So this 230 volt supply is embedded with electrical noise, and there are number of reasons for generation of electrical noise. This electrical noise most of the time is random in nature, so we cannot predict it. As this electrical noise is random in nature, proper precaution must be taken while designing the embedded products. So when I developed this automatic water level control system, initially I did not take proper precaution, and because of that there was major issue of unwanted reset. So I will talk about what are the causes of this electrical noise and how this electrical noise impact performance of embedded system. And towards the end of this topic, I will talk about how to correct this problem. So I have given here example of electrical noise. On the right hand side, you will see waveform. This waveform is laced with electrical noise. You will see random variations on the top of this waveform. So it is non-predictable or random in nature most of the times. Some of the electrical noise can be predicted. For example, harmonics produced by induction motor, it can be predicted. But there are some other type of noise which cannot be predicted in advance. This electrical noise spans from low frequency to high frequency. And as far as my experience is concerned, low frequency noise affects performance of the embedded product to large extent. Low frequency noise is called conducted emission. This low frequency noise enters into the embedded system through wires. So for example, most of the embedded system we power from AC supply. So AC supply is 230 volt. It is down converted to 5 volt or 3.3 volt depending upon controller used in the system. So as 230 volt is down converted, and this 230 volt line, as I already mentioned, consists of lot of electrical noise. So through this 230 volt, through power supply, it enters into the power supply of microcontrollers where it causes interference. This high frequency noise is called radiated emission. At high frequency, this electrical noise gets coupled to one system to another system in the form of electromagnetic waves. So it does not require wires to conduct from one location to another location. So at high frequency, this noise coupled through electromagnetic waves. That's why it is called radiated emission. Whereas at low frequency, this effect of radiation is less. It is negligible. So low frequency noise usually gets coupled from one location to another location or one product to another product through wires. I would like to play here small video. This video shows electrical noise in 5 volt supply, because most of the embedded systems we operate on 5 volt or 3.3 volt. In this short video, I am going to talk about electrical noise produced by gong bell and its effect on power supply in electronic product. So in this setup, you see here electronic gong bell, electronic product operating on 5 volt, oscilloscope to check the noise in the power supply. Electronic product and gong bell, they are connected to the AC power distribution board using. Is this video audible? Hello, is this video audible?
Yes,
Yes, sir. Yes,
Okay.
sir. Audible.
This is power cord of gong bell and this is power cord of electronic product. Output voltage of 7805 regulator is displayed on the screen of oscilloscope. This line is at 2.5 volt. 2.5 divisions multiplied by multiplier 2. This voltage is 5 volt DC. This is output voltage of 7805 regulator. Now when I switch on the gong bell, what happens is that electrical noise produced by this gong bell is conducted out of the power cord and it is placed on the wires inside the AC distribution board. Through these wires, this noise enters into the electronic product along with 220 volt AC. And this noise you have seen on the screen of oscilloscope. So noise is nothing but here unwanted fluctuations in the 5 volt supply.
Hello.
I would like to play
Hello.
another video.
Hello.
Here you will see
Hello, sir.
video of, hello,
Sir,
I hear background noise.
Yeah, sir. Which sensor is used for tracking noise?
You are not audible.
Which sensor is used for tracking the noise?
It is not sense. Can you switch off your mic so that I can answer?
Yeah.
Yeah, it is not sensor. I will talk about different type of devices which generate the electrical noise. So it is gong bell. It is used in programmable ringing bell. You know, I have developed already told you one product. This is programmable ringing bell. So in programmable ringing bell, you can feed the timetable of your college, and at the end of every lecture, this bell will ring automatically with the help of control system. So when this gong bell is switched on, inside there is a contact. This contact becomes on and off, and because of that spark is generated, and because of this sparking lot of electrical noise is generated, and this electrical noise through 230 volt AC distribution network, it may enter into the other devices connected in that area. So there are a number of sources which generate the electrical noise. Another example is electric motor. So electric motor, there are different types: DC motor, induction motor. Induction motors usually produces harmonic type of electrical noise, whereas DC motor has brushes, and at the brush there is arcing, and because of arcing, lot of electrical noise is generated. Even in stormy season, lightning strikes also generates lot of electrical noise. So there are number of sources which generate electrical noise. And if system is not properly designed, this electrical noise causes interference and creates problems like unwanted reset of microcontroller, or software running on the microcontroller may hang up. So one more video I would like to play here. This shows incorrect system design, video of water level with EMI problem. EMI stands for here electromagnetic interference. In this setup, I would like to discuss how to test reliability of electronic product. In this setup, there is automatic water level controller, AC power distribution board, and gong bell. This gong bell is source of electrical noise. The electrical noise produced by this gong bell is conducted out of this power cord, and it enters into the AC distribution board. Through this board, it again enters into the power supply of the automatic water level controller, and if it is not properly designed, it may cause unwanted reset. So let me power on automatic water level controller. So on power on, I have programmed this water level controller so as to blink 3 LEDs 3 times. Now if I switch on the gong bell, there is reset problem in automatic water level controller. This reset happen because of electrical noise produced by this gong bell. Inside this gong bell, there is contact breaker. And you will see lot of sparking. There there is lot of sparking happens inside the contactor of gong bell, and it creates electrical noise, and this electrical noise interferes with automatic water level controller here, and I have not taken proper care in order to demonstrate what is the issue related to electrical noise. Stop. Then video of water level with EMI corrected. Now I have done proper correction in the circuit of automatic water level controller, so that when I switch on the gong bell, it will not interfere with electronic circuit inside the water level controller. Let's have demonstration. You see, even though I switched on gong bell, there is no reset problem in automatic water level controller. That means my circuit is robust against the noise produced by gong bell. So whenever I develop any embedded product, what I do is, with the help of gong bell, I inject noise into the system, and then I check whether system functions properly in the presence of electrical noise produced. So I already discussed about sources of electrical noise. So whenever current is interrupted, it generates electrical noise, and intensity of the electrical noise depends upon how rapidly that current is interrupted. Usually electrical noise is also produced whenever there is arcing. So arcing takes place inside the gong bell, inside the DC motors and some other devices. Noise is also produced by digital product. Each and every digital product also produces noise. Common sources of these electromagnetic emissions are, there are two categories, wideband sources and narrowband sources. These wideband sources produce electrical noise spanning from low frequency to high frequency. Examples are spark gap, lightning strikes, relays. Relays are used for controlling AC devices with the help of embedded system. So when relay coil is switched on and up, it generates back EMF, and if this back EMF is not suppressed, it causes unwanted reset issue. To suppress the back EMF, usually freewheeling diodes are used across the relay coil. Then AC-DC electric motors also produces lot of electrical noise. Earlier days we were using fluorescent lights. So at the time of switching on the fluorescent lights, there is flicker. So at the beginning, when fluorescent light is switched on, it generates lot of electrical noise. Digital computers also produce electrical noise, because digital computers make use of SMPS power supply, and SMPS power supply usually produces lot of electrical noise. Examples of narrowband sources are high voltage power transmission lines generates electromagnetic emission at frequency of 60 or 50 Hz. Now what are the problems with electromagnetic interference? Through video I have demonstrated one issue, unwanted reset. There is another issue like software running on the microcontroller may hang up. So once software hangs up, it does not respond to the input commands. And the only solution to software hang up issue is restart the microcontroller. So once you restart the microcontroller, it will start functioning properly. Imagine you have developed either GSM based or IoT based wireless mobile at home for controlling agriculture pump. And if the software running on that system hangs up because of electrical noise, then the only problem is go at location where system is installed, reset the entire system, restart the entire system, then it will start functioning again properly. But if it happens again and again, your customer will not have satisfaction of using your product, because usually farmers use this IoT based or GSM based wireless mobile auto for controlling their agriculture pump remotely using their mobile phone. And usually distance between farmland and house of the farmer is around 2 to 3 kilometers. So imagine if system installed at farmland side malfunctions, and if it requires hardware reset, then farmer has to travel 2 to 3 kilometer distance to reset the product, and it is really hectic for the user. So interference in electrical and electronic devices is caused by intentional or unintentional sources. Electromagnetic emission that cause electronic system to work in undesired manner is called electromagnetic interference. Strong transmission from FM radio station or TV station may be picked up by digital computer, causing the computer to interpret it as data or control signal. That results in incorrect function of the computer. Noise caused by lightning discharges may also cause interference in television sets or in other embedded products. Digital computer may create emission that couple into TV, causing interference. Another example, whenever we switch on mixer grinder make use of universal motor. So whenever we switch on the mixer grinder, there is lot of parking taking place inside the mixer grinder, and this parking produces electrical noise in the low frequency band. This electrical noise produced by this mixer, it gets conducted out of the device power cord. Usually we think that power flows into the devices, but remember, direction of electrical noise is opposite of AC power flow. Electrical noise produced by any device, be it embedded product, be it motors, this noise gets conducted out of the device power cord and then it is placed on AC distribution network. And through this AC distribution network, it enters into the other devices connected to the AC power supply. So this electrical noise, for example, I have shown here television screen. This noise produced by this mixer may create interference with LED or LCD TVs. But nowadays, LED and LCD TVs are designed in such a way that it does not have any effect of noise produced by this mixer grinder. Our old television sets, they were susceptible to noise produced by these mixer grinders. And you might have observed it in earlier days. So I have shown here 3 examples. Source
Hello?
of electrical noise called emitter.
Hello?
I hear background noise. Is there any question?
Yeah, sir. How can we control electromagnetic emissions?
I will talk about in the subsequent slides. How to correct the problem? There are a number of ways to correct the problem, but as limited amount of time is available to me for this session, I will talk about one method which can be used to make your product robust. So maybe towards the end of this topic, I will talk about how to correct this EMI issue. Okay. So I have shown here one block diagram. There are 3 aspects here: source, then coupling path and receptor. So source is, example I have shown here, electric motor. Electric motors are used to do different operations, like it is used as water pump, it is used for driving the machines in industries. There are numerous applications of electric motors. And electric motor is big source of electrical noise and it cannot be prevented. So noise produced by these electrical motors is usually in the low frequency band, and this noise produced by these electrical motors gets coupled to other devices through wires. And especially I told you, this AC distribution network is made up of wires. So this noise produced by this motor gets coupled to other devices through these wires which are used for powering on the devices. So coupling path can be air path or it can be wire path. Receptor is your product, embedded product. So once noise enter into the receptor, if receptor is not properly designed, then it starts malfunctioning. So if interference occurs, if the received energy causes the receptor to behave in undesired manner. There are 4 categories of transfer of electromagnetic energy. Here you will see this radiated emission. You will see I have shown here block diagram of electronic system, especially embedded system. Embedded system consists of different type of modules, and these modules are connected with each other using wires. So in any embedded system, there may be noisy component. Let me tell you example of noisy component is electromagnetic relay or maybe oscillator. Oscillators are used in each and every embedded product. Oscillators are used for generating clock signal. So this clock module usually produces high frequency components. So clock module is basically considered as noisy component because at high frequency there is radiation. So this arrows indicates radiation. There is direct radiation from this noisy component, and when this clock signal, if it is connected from one module to another module using wires, then these wires at high frequency becomes antenna. These wires becomes antenna and then they starts radiating in the form of electromagnetic waves. So this electromagnetic waves radiated by this noisy component in the system may cause interference with nearby systems. So you will see, once this high frequency noise is placed on the wires, there is radiation. Please note that at high frequency wavelength is short, and when wavelength becomes short, any wire carrying high frequency signal, if it has dimension of related close to the quarter wavelength, then it becomes antenna, and it starts radiating as well as receiving the signal. Antenna is reciprocal, it can radiate as well as receive the waves. Second example I have shown, this electrical noise in the form of electromagnetic emission, if it is incident on the wires in the system, then these wires in the system becomes antenna. It picks up this signal, and if this signal has larger amplitude, it may cause interference. So there can be potentially susceptible components in the system. So once unwanted emission is incident on these wires in the system, it may cause interference to potentially susceptible components in the system. So this is called radiation susceptibility. This first figure shows radiated emission, and second figure shows radiation susceptibility. Two more block diagrams are shown here. Two subsystems are shown for embedded product where there is noisy component. This noisy component may produce electrical noise. This electrical noise produced by this noisy component at low frequency, which cannot be radiated. However, it can be conducted from this system to another system through wires. So noise produced by this noisy component, it may get conducted out of device power cord. So once this noise gets conducted out of the device power cord, it may be placed on AC distribution network. One example I gave about is one example I already given to you, that is gong bell. So once this noise gets placed on the AC distribution network, through this AC distribution networks, it gets entered into the other devices connected, where it causes interference. So this is called conducted emission, and this last figure shows conducted susceptibility, that is noise produced by other sources at low frequency. It enters into the system along with 230 volt, and through this 230 volt it is down converted to 5 volt. But if 5 volt power supply is not properly designed, through 5 volt power supply it enters into the power supply of the embedded system, where it causes interference with potentially susceptible component, and potentially susceptible component is microcontroller. So if strong amplitude electrical noise enters into the power supply of microcontroller, it may cause serious issues like unwanted reset or software hang-up issues. I faced both problems. I would like to share my experience about the problem which I faced due to this conducted emission. In 2016, I developed wireless mobile ATO. It is used for controlling the agriculture pump using mobile phone. That is, through mobile phone, you can switch on the agriculture pump and you can also switch it off. So when I developed first few units, I sold into the market. I did rigorous testing in my lab, but that testing was not enough. So when I sold this unit to around 10 different farmers, I faced problem at one customer site where this wireless mobile ATO was used to control 10 horsepower induction motor. You know, when horsepower rating of the motor is large, the intensity of electrical noise produced by 10 HP motor is quite high. And the problem was occasional, it was not regular. The operator which he was controlling this pump, he was coming across very critical problem, like software running on the system, it used to get hang. And he was facing this problem once in a few days, once in a week or once in a 2 week. I visited customer side couple of times, and then I understood what was the problem. That problem was electrical noise produced by motor, it was getting coupled with the microcontroller. You know, microcontroller may get hang whenever there is sudden change in content of program counter. You know, in all microcontrollers, program counter is used to save the address of next instruction to be executed. And if content of program counter is randomly changed because of electrical noise, then program is not executed in proper sequence. And that particular condition we call it as software hang-up. There are other reasons as well for software hang-up. I am talking about the software hang-up issue because of electrical noise. So when electrical noise, it is random in nature, and sometimes intensity of electrical noise is quite high. So noise produced by induction motor is not at same amplitude. It is random in nature. Sometimes its amplitude becomes so large that it may cause interference with your embedded system. Because the problem occurs, that time problem was occurring once in a few days, not regularly. So after understanding the problem, I added one component in the system. And after adding that one component, system became robust and problem did not happen later on. So what I want to tell you here is that if system is not rigorously tested, it may fail at customer side. And you cannot simulate all conditions in your lab, because I tested my system on 3 horsepower motor, which was not enough. So whenever you develop any type of system, at the beginning, do not sell at large quantity. Sell few number of units to the customer, get feedback, and then start selling the system in large scale. Then another problem is voltage spikes and transients. This figure shows waveform of AC voltage, 230 volt AC. This AC voltage is again always not pure. It is embedded with noise, and many times there are voltage spikes. For example, this 230 volt AC is RMS value. 230 volt is RMS value. Let me tell you what is the problem. RMS value of 230 volt, is 230. 230 is the RMS value. So when you multiply it by root 2, you will get peak voltage. So peak voltage 230 into root 2. So it will be around 330 volt. I am writing rough value, around 330 volt. So this peak value will be at 330 volt. Whenever transient occurs on the AC line, this transient may reach peak value up to 450 or 500 volt. So while designing the embedded system, especially power supply, most of the embedded system make use of SMPS power supply. If this SMPS power supply is not properly designed, it cannot withstand this transient voltage, and some of the component may get damaged. Another problem with transient is if power supply is properly designed, but this transient voltage creates transient noise in the 5 volt supply, and if amplitude of this transient noise is quite large, it may cause malfunctioning of the embedded product, that is unwanted reset, or software running on the microcontroller may get hang up. So these are the serious problems. Now how to correct this problem? There are a number of ways. I am telling you, there are a number of ways to correct these EMI problems. One method I am going to discuss, maybe after this slide. Before I discuss correction of this problem, I would like to bring your attention to limitations of Arduino and Raspberry Pi boards. In 2015, I told you I developed wireless mobile ATO for controlling the agriculture pump using mobile phone. Before that, one of my student group, they use Arduino board for developing this wireless mobile ATO, and it was using GSM. That is, by sending the SMS, this agriculture pump can be switched on. So they use Arduino board, and most of the Arduino boards make use of Atmega series microcontrollers. We use Atmega 328 controller. Atmega 328 controller we use in prototype development of this wireless mobile ATO. After developing this prototype, we tested in mechanical engineering department laboratory, where we have 7 horsepower motor. So after interfacing with motor, we gave the command through mobile phone to switch on the motor. When motor was switched on after giving the command through mobile phone, the controller got reset. immediately after switching on the motor, because motor started producing a lot of electrical noise. After that, we restarted the system and again we gave the command second time through mobile phone. Again, motor got started and controller got reset. Third time we repeated our trial. After giving the command third time, motor started, but program saved in the flash memory of that mega series microcontroller got corrupted. After that, even after restart, we could not control the motor because program saved in the flash memory got corrupted because of electrical noise. Usually microcontrollers make use of flash memory for saving the program, saving the user program, and flash memory in at mega series microcontroller is susceptible to electrical noise. So program saved in the flash memory is not able to retain in the presence of extreme electrical noise. I am talking about here extreme electrical noise. So based upon my experience, I can say these at mega series microcontrollers are not suitable for industrial or commercial application. Especially in industry, there is a lot of electrical noise. There, this at mega series microcontroller, even though you add EMI filter, they are not reliable and they will definitely malfunction. So this at mega series microcontroller lack reliability, and most of the Arduino boards, they make use of this at mega series microcontroller. Here I don't want to say that do not use Arduino boards. Arduino boards are easy to use. Lot of codes are available online, free of cost. So you can download the codes, you can modify them, you can customize according to your need, and you can validate your idea. So Arduino boards are suitable only for validation of idea. They are not suitable for commercial product. So they have poor endurance of flash ROM and they lack reliability. Another problem is susceptible to transient noise and other interferences. Like there may be issue of unwanted reset or software hang-up issues. Even though you use industry grade microcontroller, it may be susceptible to electrical noise if system is not properly designed. I told you that in 2016 when I started selling wireless mobile auto. In that wireless mobile auto, I used industry grade microcontroller PIC18F4520. Besides that, it was susceptible to electrical noise. So proper precaution must be done in system design to avoid these problems. I have already told about Arduino boards. I would like to also share you about experience of Raspberry Pi boards. Few years back, we implemented this IoT based wireless water management system for our campus using Raspberry Pi board. After deployment of the system, it worked reliably for 2 to 3 days. After that, it stopped working. And the problem was excess heat. The processor used in Raspberry Pi board, usually it heat up extensively, leading to slowdown of the software running on it and other issues. So if you use Raspberry Pi board 24/7 continuously, it may malfunction. I am telling you my experience. You can validate on your end. So my experience is Arduino and Raspberry Pi boards are not suitable for commercial products.
Hello.
Yeah.
Hello.
Yeah. Please ask your question. You are audible. Hello.
Sir, what is the difference between Raspberry Pi and Arduino?
In Raspberry,
What is the difference between Arduino and Raspberry?
Yes, I tell. In Arduino boards, usually at mega series microcontrollers are used, and in Raspberry Pi board, ARM context processor is used. So this is the major difference. In Raspberry Pi board, you can implement high-end applications like image processing, where it is quite difficult with Arduino board. And in Raspberry Pi boards, usually there is operating system. In Arduino boards, there is no operating system. But yes, real-time operating system, embedded operating system can be implemented in Arduino boards. But Raspberry Pi boards comes with operating system where you run your application. So this is the major difference.
Okay, thank you so much.
Yeah. So what I will do after lunch break, I will discuss how to correct some of the problems arising because of electrical noise by making use of ferrite bead. And then I will present case study on IoT based saline monitoring control system and other two products developed in-house in our department.
Hello.
So we'll have lunch break for 1 hour. We'll once again meet at 2:30.
Hello.
Okay, sir. Thank you, sir.
Hello. Thank you very much, Kakade sir,
Yeah,
for
thank you.
your valuable guidance. And you explained details regarding the design aspects of the IoT applications. In that, you explain how noise is generated and how to eliminate that noise. Also, you explain very nice about the limitations of the Arduino and Raspberry Pi IoT platforms. What is the difference between these two boards? Thank you. These are the important aspects in designing the IoT applications. Thank you very much, sir.
Thank you.
So there is a lunch break and you have to rejoin at 2:30 p.m. Participants are requested to rejoin at 2:30 p.m. sharp.